Under the vast expanse of the celestial sphere, a massive scarlet star, among the most luminous and easily distinguishable stellar bodies, asserts its dominance along the horizon. Situated far beyond our full understanding, this immense cosmic entity possesses the capability of releasing an energy magnitude that could rival the combined radiance of an innumerable array of stars. This astronomical giant, possibly on the verge of an apocalyptic event, may soon unleash an energy burst of such magnitude that, 32 seconds, it could outshine a billion suns. The real question is, are we prepared for the aftermath such an event could bring? This colossal red star, often referred to as Goliath, resides relatively close to Earth and has emerged as a subject of significant fascination and debate within both the scientific community and the broader public. Recently, this star underwent a considerable transformation, prompting growing concerns among researchers and fueling intense discussions regarding its future trajectory. The most alarming possibility is that this alteration might signal the early stages of a supernova, an explosive stellar phenomenon marking the final phase in a star's life cycle. If Alpha Orionis, the scientific name for this star, were to exhaust its nuclear fuel, it might collapse under its own gravitational pull, triggering a catastrophic explosion. The very thought of such an event sparks anxiety, not just among scientists but also among those of us inhabiting Earth, as the potential consequences could be extraordinary. Alpha Orionis, easily recognized by its deep crimson hue, holds the title of being the largest and most radiant star in the Orion constellation. With the aid of advanced tools such as NASA's Hubble Space Telescope, astronomers have closely observed its behavior, particularly in 2019, when it experienced a dramatic loss of mass. This phenomenon, considered rare for stars of this type, raised alarms across the scientific community. While our Sun frequently undergoes coronal mass ejections, the unusual event witnessed in Alpha Orionis has sparked a re-evaluation of what occurs during the final stages of a massive star's life. 2 minutes and 7 seconds. Scientists are currently divided over the precise distance of Alpha Orionis from Earth. Estimates vary, with some placing it as far as 1,200 light-years away, while others suggest it might be as close as 724 light-years. The difficulty in accurately determining the position of stars like Alpha Orionis lies in the immense distances involved and the peculiar nature of red giants. Despite uncertainties regarding its precise location, Alpha Orionis continues to captivate observers as one of the most awe-inspiring objects in the night sky, shining several times brighter than our Sun. However, this radiant glow comes at a significant cost. Alpha Orionis is consuming its nuclear fuel at a rapid pace, accelerating its journey toward the inevitable end of its life cycle. Once it exhausts its fuel supply, the star will likely collapse, possibly forming either a neutron star or, in a more catastrophic scenario, a black hole, depending on the manner in which the explosion unfolds. This leads to a pressing question: could Alpha Orionis pose a threat to Earth? Should a supernova occur within a few light-years of our planet, the ramifications would be devastating. A supernova can release an unimaginable amount of energy, potentially outshining entire galaxies, which presents the possibility of far-reaching consequences. Even if Alpha Orionis lies at a considerable distance from our planet, the potential impact cannot be ignored. 3 minutes and 47 seconds. Historically, the last supernova event recorded within our galaxy took place in the year 1604. Since then, humanity has not witnessed a similar occurrence on a local scale. However, a significant supernova erupted in 1987 in the Large Magellanic Cloud, located a staggering 169,000 light-years away. Although this explosion had notable consequences for its immediate environment, it posed no direct threat to Earth. Nonetheless, these rare events serve as potent reminders of the immense scale of supernova explosions and the dangers they may present. A supernova, particularly one occurring close to Earth, could create what has been termed a danger zone around the stellar explosion. The risks to life on Earth, however, should be viewed in the broader context of cosmic events. While supernovae are infrequent occurrences, gamma-ray bursts, GRBs, represent an even more potent threat. These bursts are capable of annihilating entire planetary biospheres, flooding them with deadly radiation. For instance, GRBs have the potential to destroy a planet's ozone layer, leaving it exposed to harmful ultraviolet radiation from its sun, effects that could persist long after the burst itself has subsided. 5 minutes and 27 seconds. This looming threat of gamma-ray bursts has become a focus of recent research, shedding new light on the potential hazards associated with stellar explosions that culminate in such dramatic and destructive events. When massive stars explode as supernovae, their brightness can surpass that of entire galaxies. This intensity raises an important question. What would happen if Alpha Orionis were to undergo a similar transformation? Should it explode as a supernova, it could become the second brightest object in the sky, second only to the Sun in terms of visibility. Even at a considerable distance, the energy released in such an explosion might be so intense that it could be visible even during daylight hours. This blinding spectacle would cast shadows in the middle of the day, offering a striking yet unnerving experience for those witnessing it. However, while the visible light emitted by a supernova would undoubtedly be a breathtaking sight, the real threat lies in the high-energy radiation accompanying such an explosion. 6 minutes and 58 seconds radiation, typically in the form of X-rays and gamma rays, would have far-reaching consequences. One of the most pressing concerns is its potential to deplete Earth's protective ozone layer. Without the ozone layer, life on Earth would be exposed to harmful levels of ultraviolet radiation, potentially leading to extinction events. The dangers posed by a supernova do not cease immediately after the explosion. The remnants of the explosion, including shock waves traveling at nearly the speed of light, would continue to pose threats as they spread throughout the solar system. These shock waves could further damage the ozone layer, subjecting Earth to an even greater risk of harmful radiation, which would only heighten the dangers over time. As scientists analyze the long-term consequences of a supernova explosion, one lingering question remains. How would Earth's biosphere react to such an event? Some theories suggest that even if the initial radiation burst did not cause immediate extinction, the resulting climate disruptions could have profound effects on planetary ecosystems. Dust and debris from the explosion could potentially alter Earth's atmosphere, triggering shifts in global temperatures and weather patterns. Such an event might resemble a cosmic-scale version of a nuclear winter, where sunlight is partially blocked by suspended particles, leading to prolonged cooling and disruptions in agriculture. If Alpha Orionis were to undergo this transformation, it would not simply be a spectacle of the night sky, but a moment that could shape the trajectory of life on Earth itself. 8 minutes and 5 seconds yet, amidst the potential for destruction, supernovae also bring creation. These violent stellar deaths scatter elements essential for life, carbon, oxygen, and even the iron in our blood, into the cosmos. Over millennia, these materials coalesce into new stars, planets, and, perhaps, new life. Astronomers have long speculated that Earth itself was born from the remnants of ancient stellar explosions, making every living organism a descendant of the universe's most powerful forces. The cycle of life and death, at both the cosmic and biological levels, is intertwined in ways we are only beginning to understand. However, understanding these events is not just an exercise in scientific curiosity. The more we learn about supernovae, the better prepared we may be for their consequences. Researchers are developing methods to detect early warning signs of impending stellar explosions. By studying fluctuations in a star's brightness, shifts in its spectral composition, and even neutrino emissions, astronomers hope to predict when and where the next supernova might occur. 9 minutes and 9 seconds. Could humanity ever protect itself from the dangers of such an event? Some have speculated that advanced civilizations, if they exist elsewhere in the universe, might have developed strategies to shield their planets from supernova radiation. Concepts range from artificial magnetic fields to deflect cosmic rays, to interstellar migration, ensuring survival beyond a single planetary home. For now, Earth's best defense lies in understanding. With every discovery about Alpha Orionis and other dying stars, we move closer to grasping the vast, dynamic forces shaping the cosmos. Whether Alpha Orionis explodes within our lifetime or in the distant future, its fate will be a reminder of our fragile yet profound connection to the stars. And when that moment arrives, when the sky ignites with a brilliance not seen in human history, it will be a testament to the grand and ceaseless dance of the universe, where creation and destruction are but two sides of the same cosmic coin. As astronomers closely monitor Alpha Orionis, anticipation builds. While its explosion remains uncertain, the mere possibility has sparked intense discussions across scientific communities, governments, and even the public. What would humanity do if a nearby supernova were imminent? Though modern civilization has harnessed incredible technological advancements, our ability to withstand a supernova's impact remains untested. Some researchers argue that preparations should begin now, not only for the potential radiation and shockwaves but also for the broader implications of such an event. 10 minutes and 12 seconds. The first challenge would be mitigating the effects of high-energy radiation. A direct gamma-ray burst from the explosion could devastate Earth's upper atmosphere, stripping away the ozone layer and exposing the surface to lethal ultraviolet rays. Some propose that artificial magnetic fields, space-based shielding systems, or even global underground refuges could serve as protective measures. But even if Earth's biosphere remains intact, the psychological and societal impacts of witnessing such a cataclysmic event could be profound. History has shown that celestial events, comets, eclipses, and meteor showers, have often been interpreted as omens, shaping cultures and belief systems. A supernova, visible even in daylight, casting shadows at noon, could ignite existential debates on an unprecedented scale. 10 minutes and 45 seconds. Beyond Earth, a new perspective is emerging. If supernovae are inevitable, perhaps our survival lies not in shielding ourselves but in expanding beyond our planetary cradle. The renewed focus on space exploration, Mars colonization, and interstellar travel takes on an urgent dimension. Could humanity become a multi-planetary species before a supernova alters the very conditions that make life possible on Earth? If Alpha Orionis were to explode tomorrow, we would witness not just the death of a star but a glimpse into the cosmic forces that shape the fate of galaxies. The energy released would serve as a reminder of our universe's raw power, a force capable of both destruction and renewal. 11 minutes and 16 seconds. As humanity watches and waits, the stars remain indifferent. Alpha Orionis may erupt in 1,000 years, or 100, or perhaps within our lifetime. But its destiny is sealed, written in the fabric of space and time. And when that moment comes, when the night sky is set ablaze with the dying breath of a red giant, one question will echo across the cosmos. Are we ready?